Hello everyone and welcome to Solving with Exponents. It is my assumption that you either know your exponent rules and you're looking at that page, you have them memorized, or you've just watched the explanation of exponent rules and you kind of know what's going on there. You did not have to watch that video, but I am assuming you're watching this video knowing those rules. So now that you know the rules, let's start by solving. But before we get to solving, I want to just name a few parts of an exponent. So if we have, let's say 5, let's call that 5 to the 6. The 5 there is going to be your base, and the 6 is going to be your exponent. So you're going to hear me use these words. Hopefully you already know the one exponent. But let's get to solving. So we can say 5 to the 6 is the same as 5 to the 6. We can also say that 5 to the 6 is the same as 5 to the 2 plus 4. These all mean the same thing. But what if we replace one part of that exponent? What if we said 5 to the 6 is equal to 5 to the x plus 4? How could we figure out what x is? Well, since we have two bases that are the same, that are equal to each other, once those bases are the same, I can cancel those out and just set the exponents equal to each other. So if 6 is equal to x plus 4, I'll subtract 4 on both sides, and I get that 2 is equal to x. So our goal when we are solving is to make sure we get the same base, or that same big number, so then we can set our exponents equal to each other. I'm going to be working through all 6 problems on page 7 from the 4.3 exponent or exponential functions. So let's move to that page. We can see those right here. I'm going to zoom in. The instructions say solve the following equations, and then, where's my highlighter? List your solution set. So all of our answers we're going to be putting into a solution set. I mentioned that during Unit 1. It's going to be much more important in the next unit, but I want us to start practicing now. Solution sets are just the curly brackets. So let's start with problem A. So if we're taking a look at problem A, I have 5 to the x is equal to 5 to the negative 6. I'll zoom in even more. And I go, oh, we essentially just did that, right? We have two numbers of the same base. We can cancel, oh, that's still a highlighter, my bad. There we go. We can cancel out the same base. Oh, that was supposed to be red, oh well. And we get x is equal to negative 6. Cool, done. Except I want to put this into a solution set. So this is going to go in curly brackets, and the solution set says, hey, here are all the solutions that could possibly work. Instead of going A, B, C, D, E, F, I'm going to be going sideways. So the next one I'm going to do is problem D. So we have 2 to the 2x minus 1 is equal to 4. Now I look at this and I go, okay, 2 and 4, those are not the same number. How can I turn this 4 into a base of 2? So I'm going to say this is 2 to the 2x minus 1 is equal to 2. And then I ask myself, to the what? This is going to be 2 to the power of 2. And now that I have the same base, I can cancel those out and set my exponents equal to each other. Or 2x minus 1 is equal to 2. And from here, I'm just going to solve like normal. So let's see, I'm going to add 1 to both sides. So we get 2x is equal to 3. Divide both sides by 2. And I get x is equal to 3 halves. And again, make sure that you please put your answer into a solution set. You'll notice that my curly brackets are never even. That is totally okay. All right. Actually, I'm just going to skip around. Let's do E next. E is very, very similar to D, except now we have 2 to the 3x minus 1 is equal to, let's see, 32. I need to find out how to turn that into a base of 2. So you can do this by guessing and checking, or if you know you're doubling, it's going to be 2, 4, 8, 16, 32. That was my 5th number. So this is the same as 2 to the power of 5. Again, if you're not sure, guessing and checking in a calculator is totally a valid option. If anyone was wondering what that beeping was, my oven is now preheated. I'm also in the middle of making dinner. Anyway, now that we have both of our bases the same as a base of 2, we can cancel out our bases and have 3x minus 1 is equal to 5. I add 1 on both sides, so 3x is equal to 6. divide both sides by 3, and I get x is equal to 2. So I'm going to put my answer into a solution set, and we are done. Let's keep moving around. Let's try problem B. So I look at problem B, and I go, okay, base of 4. 4 to 2x minus 5 is equal to 1 over 16. Well, I know that 16 is 4 squared, so this is 1 over 4 squared, but I can't cancel things out here. I really need this to be equal to 4 to the power of something. So we're going to use our negative exponent rule here. I'm going to say this is 4 to the power of negative 2. So now that our bases are the same, we're going to cancel out the 4's and get 2x minus 5 is equal to negative 2 and solve from there. So we're going to add 5 to both sides. Get 2x is equal to 3. Divide both sides by 2 and we get x is equal to 3 halves. And don't forget to put that into a solution set. So hopefully these problems are not too bad. It's really, do you know your exponent rules? If you know your exponent rules, you're going to be fine. Let's do the next two problems because those get a little bit more exciting. So problem C, this is 5x to the power of x squared plus 8 is equal to, let's see, 125. I know I need this to be with the base of 5, and you can guess and check, or you may just know that 125 is the same as 5 to the power of 3. We're going to put that in parentheses because that's still to the power of 2x. So now we're going to be using our power rule and multiplying those exponents together. So we'll have 5 to the x squared plus 8 is equal to 5 to the 6x. And now we're like, oh yes, our bases are the same. We can cancel those out. And we're left with x squared plus 8 is equal to 6x. So I look at this and I go, okay, something with an x squared, something with an x, and something with a constant, I'm probably going to have to factor. So I'm going to subtract 6x on both sides, get x squared, minus 6x plus 8 is equal to 0. And then I'm going to factor. So remember, we're looking for two numbers that multiply to 8 and add to negative 6. In this case, that is going to be negative 4 and negative 2. So we'll have, we'll have x minus 4 times x minus 2 is equal to 0. So now we have to solve for x. We'll say that x minus 4 is equal to 0, and x minus 2 is equal to 0. So we'll get that x is equal to 4, and x is equal to 2. Now when we put our answers in a solution set, make sure that you put them in order of least to greatest. So our solution set is going to look like 2, 4. And these are possible answers. Let's try problem F. This one's going to get a little bit tricky because now I see multiple numbers here. I see more than just 2. So we have a 9, a 27, and a 3. Usually you're going to want to set this to the lowest number, in this case 3. So 9 is going to be 3 squared to the power of 2x times 27, which is 3 to the power of 3 to the power of x squared, which is equal to 3 to the negative 1. So we're going to use our power rule for both of those first two bases. So this is going to be 3 to the 4x times 3 to the 3x squared, which is equal to 3 to the negative 1. So I know that all of my bases are the same now, but I still cannot cancel them out yet. First, I have to deal with this. I have to use my exponent rules and add these two together. Remember, this is the product rule. So this is going to be 3 to the 3x squared plus 4x, I'm adding my exponents together, is equal to 3 to the negative 1. And now that I just have one base on either side, now I can cancel those out. And we get 3x squared plus 4x is equal to negative 1. So I look at this, again, something with a squared, something with an x, something with just a constant, probably going to have to factor. So I'm going to add 1 to both sides. I'm going to get 3x squared plus 4x plus 1 is equal to 0. But I look at this and I go, oh, I don't really know how to, this year we have not gone over how to factor with an a value greater than 1. It's something that we would have worked on just throughout the units that we've already done so far, but as with this current environment, we've been taking some things out, and this is one of the things. So if you're not sure how to factor with something when the a value is not 1, meaning that like this right here is 3x squared as opposed to just x squared, there is something that's always going to work every single time no matter what. So I'm going to move this over a little bit so that we can have some space. Something that is always going to work, and feel free to sing this with me, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you've been in my EGS2 class, you know there's a video on YouTube that I love of like a little weasel kind of like dancing along because it's to the tune of Pop Goes the Weasel. So feel free to YouTube the quadratic formula song, but the quadratic formula will always work. So remember, this is our A, our B, our C. Let's plug this in and solve. See, this is going to be x is equal to negative 4 plus or minus the square root. You're going to hear me sing a lot. I'm not apologizing. Oh, things are done cooking. I'll be right back. I'm back. So now we're going to have the square root of b squared, which in our case is 4 squared, minus 4 times our a value of 3 times our c value of 1, all over 2 times our a value of 3. So let's see, this is going to be x is equal to negative 4 plus or minus the square root of 16 minus 12 over 6, or x is equal to negative 4 plus or minus square root of 4 over 6. Cool thing is, we know square root of 4, it's going to be 2. So it's going to be x is equal to negative 4 plus or minus 2 over 6. I'm going to bring this back into our problem and separate this out into 2 separate problems. We're going to have x is equal to, oh, this should go back to black. Nope, here we are. X is equal to negative 4 plus 2 over 6, and x is equal to negative 4 minus 2 over 6. So when we solve for the first one, we're going to get x is equal to negative 2 over 6, or reduced, x is equal to negative 1/3. And in our other one, we're going to have x is equal to negative 6 over 6, or x is equal to negative 1. So when I put this in my solution set, remember, you're going to go least to greatest. So in this case, negative 1 is smaller than negative 1/3. So we're also starting to bring in those algebra skills that we really need to know. Quadratic formula is totally fair game. That is something that I assume that you know. So this was practicing all of our problems from the 4.3 kind of notes. Take a look at the solving with exponents day 1 practice problems, and we'll go over that tomorrow. I look forward to seeing you tomorrow.